Yeah, welcome again to uh, mathematics class. Once again, my name is Oladotu, and then I will be taking you through the Pearson Edexcel paper 2, January question. So we will be looking at this together. So I invite you to join and register with Ajiro Tech, where we will teach you more and give you inside information on how you are to answer each questions and also how to do better and achieve excellence in your results. So welcome to class once again. So join me as we start this session. Okay, we are starting with the first question here that talks about binomial expansion. Okay, so it says find the first four terms in ascending powers of x of the binomial expansion. So this is what we are to expand: 3 plus kx to the power of 7. Okay, so there's a formula to use to solve this. And the formula is, take for example, you have a binomial, okay, raised to the power of n, where n is, let's say n is um, um, an integer, okay, an integer, or let's say a positive integer. Let's use a positive integer or a natural number, okay. So we say a plus b to the power of n equals to n combination 0, a raised per n plus n combination 1, a n minus 1, b plus n combination 2, a n minus 2, b squared plus n combination 3, a n minus 3, b cubed, then plus continues like that. Okay, so we are going to use this. So if we compare this with what we have, our a is 3 and our b is kx, where our n is 7. So let's plug that in inside the formula. So we are to find the first four terms: 3 plus kx to the power of 7. So we have 7 combination 0, 3 raised to the power 7, plus 7 combination 1, 3 raised to the power 6, that's 7 minus 1, 6, multiplied by kx raised to the power 1, then plus 7 combination 2, okay, 3 raised to the power 5, that's 7 minus 2, multiplied by kx all squared, then plus 7 combination 3, 3 raised to the power 4, multiplied by kx raised to the power 3. So if you observe, the powers, the sum of the powers equals to 7. Okay, and as the power of a is decreasing, the power of b is increasing. So that's one way to know you're sure. So 7 combination 0, we can use our calculator from here now. So 7 combination 0 is 1. Okay, so 3 raised to power 7. What is 3 raised to power 7? Let's do that. 3 raised to the power of 7. 3 raised to power 3 raised to the power of 7 is 2,187. Multiplied by 7 combination 1 is 7. Okay, then 3, sorry, this is plus, yeah, this is plus, yeah. Okay, so 7 combination 1 is 7. 3 raised to the power of 6 is 729, then multiply by kx plus 7 combination 2. So 7 combination 2 is 21. 21 multiplied by 2 raised to the power of 5 is 243. Okay, then multiply by k square x squared, then plus 7 raised to the power of 3. Sorry, 7 combination of 3 is 35. 3 raised to the power of 4 is 81. Then multiply by k cube x cube. So we have 2,187 plus, so 7 times 729 is 5,103 kx plus 21 multiplied by 243. It's also 5,103 k squared x squared plus 35 multiplied by 81. 35 multiplied by 81 is 2,835 k cube x cube plus dot 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 to show that it continues. So that's the first 4 term in ascending powers of x. Okay. The second part says that so it's in simplified form. Okay. So the second part says that given that this expansion, in this expansion, the coefficient of x squared is 3 times the coefficient of x cubed. Find in simplest form the value of k. So we have to go back to what we have there. What's the coefficient of x squared? The coefficient of x squared here is 5,103 k squared, because k is a constant. So the coefficient of x squared is 5,103 k squared. And the coefficient of x cube, is 2,835 k cube. 2,000 coefficient of x cube is 2,835 k cube. So we're told that the coefficient of x squared is 3 times the coefficient of x cube. So we are saying that 5,103 k squared is 3 multiplied by 2,835 k cube. So we have to find the value of k. So if we decide to divide both sides by 5,103 k squared divided by 5,103 k squared. Okay, so we have this one cancel this, so k squared cancel k squared. So this is times 3, then divided by 5,103. So we have k, 1k. So here we have 1 equals to 5 over 3k. So making k the subject of formula, k is definitely going to be 3 over 5. So because it told us that k is not a 0, it's non-zero. So k equals to 3 over 5. Okay, can we move on to the next question? Okay, so we have this. We have this diagram, figure 1. So figure 1 shows a sketch of path of the curve C. So we can see the curve C with equation y equals to 2 raised to power negative 0.1x. The table below shows corresponding values of x and y for this equation. So we have the y value are given to 4 decimal places, each of them to 4 decimal places. The region R, so this is the region R, is bounded by C, that's the curve C, the x-axis, okay, this x-axis, then these two lines, x equals to -4 and x equals to 11. So we have to use the trapezium rule with all the values of y in the table to find an estimate for the area of y. Give the answer to 2 decimal places. Okay, so we have to use the trapezium rule. So the trapezium rule formula says that the trapezium rule is an approximate or a numerical method for solving questions relating to integration. Okay, it's like it helps us to get a very close and approximate answer. We have different types of numerical solutions or approximate solutions. We have the trapezium rule, we have the Simpson rule, we have different forms, we have the ordinate rule, different rules. Okay, so but here we are going to use the trapezium rule, and it is important we know what the trapezium rule says. It says this is going to be approximate, okay? Area is approximate because it's an approximate solution. A to B of f of x dx, okay? And it says that when we have this approximately, the formula is h over 2, okay? Y naught plus yn plus 2 into y1, that is the order ordinates, and so on like that. So it depends on the number of strips that you have that will determine this. So here we have 5. So we have y naught to y5. So you can decide to call this one y naught, okay? This is y1, y2, y3, y4, and y5, okay? Then our h is talking about the difference, okay? We can call it interval, which is talking about xh is always equals to xn minus x naught. Okay, xn minus x naught. So yeah, we can say that overhand, or you can decide to say h is equals to x1 minus x naught. Okay, you can actually use that, or you can use this general formula to find the value of your h. Okay, so if I decide to use this as my, this is going to be my x naught, x1, x2, x3, x4, x5. So the number of ordinates that we have here, or the number of strips that we have here. So our h, which is x1 minus x naught, is -1 minus -4, and that should be -1 plus 4. That should be free. So h is free. And it's always constant when you are using the trapezium rule. Your h must always be constant. The difference between each ordinate must be the same for the value of x. Okay, so everything we need here is set. Our h is free over 2. Okay, so our y naught is 1.3195. Then our yn, which is the last ordinate, is 0.4665 plus 2 into the remaining ordinate, which are the sum of all of them, 1.0718 plus 0.8706 plus 0.7071 plus 0.5745 free. So that's the remaining ordinate we have. So we use our calculator to solve this. So let's try and use a calculator to add everything together. 1.3195 plus 0.4665 plus 2 multiplied by 1.0718. You have to be careful while you're pressing your calculator, punching your calculator. 0.8706 plus 0.7071 plus 0.5743. Okay. So we have everything to be 8.2336. So we multiply that by 3/2, 1.5. So we have the answer to be approximately 12.3504. But the question says our answer should be to 2 decimal place to get the final accuracy mark. So this will be 12.35 to 2 decimal place. So this is how to use the trapezium rule to find this. Okay. Okay, can we move on to the next question here? Okay, we have a follow-through question that says that, so state how you would use the trapezium rule to get a more accurate estimate for the true area of y. Don't forget I told you that the trapezium rule is an approximate solution, okay? We can algebraically, okay, we can decide to solve this question, -411, using integration, 2 raised to the power minus 0.1x dx, okay? We can decide to solve this. We get an exact answer if you solve it algebraically, okay? But the trapezium rule is just to help us get a very close answer, okay, approximately to the original, the exact answer. And that's actually what you call error estimate, the error theory, difference between the exact value and the numerical solution or approximate solution, okay? But we are not going into that. So for us to have this, the best thing to do is when we reduce the distance between each strips, okay, and we make it more narrow, we have more trapezium, okay, it will help us to get a better or a more accurate result. Yeah, now we have, we can say we have 5 strips inside this, okay? We can say 5 strips, okay? But if we increase the number of strips we have, then our answer will be more accurate. So we can say that, okay, we can reduce or we can increase the number of strips or ordinates to obtain a more accurate solution, which is close or closer to the true area of R. So you have to give it contextually. So that gives you the mark for that. So that means the more the number of strips, the more accurate our solution is. Okay, so we make it more narrow for us to get that. Okay.
Mathematics is more than numbers. It's the language of logic, problem solving, and precision. At Ajiro Tech Tutoring, we make math make sense. From algebra and geometry to statistics and calculus, vectors, and all. Our expert tutors bring clarity and confidence to every topic. We specialize in all major exam boards: AQA, Edexcel, and Cambridge International, helping students prepare effectively for their GCSE, IGCSE, and A-level exam. Each lesson is personalized, interactive, and focused on building understanding that lasts. And now, we're proud to be officially registered right here in England, UK, offering you trusted, high quality online tutoring that meets British educational standard. Because when students understand the why behind the numbers, success become inevitable. Begin your journey today at agiletech.com or message our sales team info@agiletech.com or agiletech@gmail.com. Agile Tutoring, where understanding leads to excellence.
So we have this, a follow-through question, say using the path, the answer to part A and showing your result. Estimate this. So we have to estimate -4 to 11, 2 raised to power 3 minus 0.1x dx. Okay, so we are to use our answer to part A. So what we need to do is, okay, this one actually look like what we have in part A. What we have in part A is integral of -4 to 11 of 2 raised power minus 0.1 x dx. Okay, so how can we do this? We can write 2 to the power of 3 minus 0.1 x. We can write it as 2 to the power of 3 multiplied by 2 to the power of minus 0.1 x. So definitely we can say that -411 to 3 minus 0.1 x dx can also be written as -411 2 raised to power 3 multiplied by 2 raised to power minus 0.1 x dx. So this 2 raised to power 3 is a constant, that's 8. So we can write it as 8 integral of -4 to 11 2 raised to power minus 0.1 x dx. Okay, so definitely we have this to be 8 multiplied by, what was the answer we got for this? We had, let's go back to check that. Let's go back to check that. So we have 12.3504. So we can decide to use 12.35. It's fine. So 12.3504. So we multiply this by 8 and we get our answer to be 98.8032, which to 3 significant figure will be 98.8. Okay, so that should be the answer for that question. Okay. Okay, so that should be the answer for that. Let's move on. Question 3 is a question on polynomials. Okay, so it's a given that f of x equals 4x raised to power 3 plus 6x plus k, where k is a constant. You have to be sure of that. And that's what we know about k. It's a constant. So x plus 2 is a factor of f of x. We have to find the remainder when f of x is divided by x minus 5. So this is the first thing we need to take note of. X plus 2 is a factor. Okay, and if x plus 2 is a factor of f of x, then from factor theorem, f of -2 will be equal to 0. That is, the remainder will be 0. So for us to get the value of our unknown, to know what k is, let's plug that in. So we can say that 4 into negative 2 raised to power 3 plus 6 into negative 2 plus k equals to 0. So negative 2 raised to power 3 is negative 8 multiplied by 4. That's negative 32 minus 6 times negative 2 is going to be negative 12, then plus k equals to 0. So this is negative 44, then k equals to 44. So that means that our function originally is 4x cubed plus 6x plus 44. So this is what we have as our function. That's our polynomial of degree 3. So we're told that we should find the remainder when it's divided by x minus 5. So we have to find the remainder. So when it is divided by x minus 5, we can use the factor theorem to check that. So x minus 5 equals to 0. Okay, so that means x equals to 5. So let's plug that in, because we know that if it's a factor, then f of x will be, f of that number will be 0. So we have 4 into 5 raised to the power 3 plus 6 into 5, okay, plus 44. Okay, so this is going to be 5 raised to the power 5. 5 raised to the power 3 is 125. So 125, 4 times 125, that's 500 plus 30 plus 44. And that should be 574. So the remainder is 574. So that should be the remainder when it is divided by x minus 5. Okay, let's move on to the next question. Let's move on to the next question. So another question under this says that find the remainder. Okay, find the remainder r and the quotient q of x when 6x cubed minus 15x squared minus 21x plus 8 is divided by 2x plus 3. So we can use the remainder theorem that says that this is our dividend and this is our divisor. So it says dividend, which most time we call polynomial of x, or is equals to quotient multiplied by the divisor plus the remainder. Okay, so we say this is q of x multiplied by the divisor, then plus the remainder. Okay, so here the divisor is 2x plus 3, the dividend is 6x cubed plus 15x squared minus 21x plus 8. So we have to find the quotient and the remainder. Now, what we need to know here is that the power of the dividend is 3. And the power of the divisor, the degree of the divisor is 1. So that means we take away the number of power of the divisor, we take it away from the dividend. Okay, that gives us 2. So that means the quotient, the degree of the quotient will be 2. And the degree of the remainder is always 1 less than the degree of the divisor. So that means our remainder here is going to be a constant term. So we have 6x cubed minus 15x squared minus 21x plus 8 equals to, so we don't know the quotient, we can represent it to be ax squared plus bx plus c, then multiply by 2x plus 3 plus our remainder is just going to be a constant. Let's call it d. Let's call it d. So we have this. Let's expand this so we can compare both sides. So we have this to be 2ax cubed plus 3ax squared plus 2bx squared plus 3bx plus 2cx plus 3c plus d. So we're comparing the left-hand side and the right-hand side. Okay, so that's plus 8. Okay, let me write it very properly. Okay, good. So if we compare both sides, compare and equate them. Compare both sides. So if you compare the coefficient of x cubed, in the left-hand side we have 6, while here we have 2a. Then it means a equals 3. Okay, let's compare the coefficient of x squared. In the left-hand side, we have it to be negative 15 equals to, here we have it to be 3a plus 2b. Already we know our a is 3, so this is going to be minus 15 equals to 3 times 3, that's 9 plus 2b. So if we take this one to the other side, we have 2b to be equals to minus 24, then b equals to minus 12. Okay, good. Then if we compare to get the value of c, we can compare minus 21. So x, let's use the additional page. So x, the coefficient of x here is negative 21 equals to, the coefficient of x here is 3b plus 3b plus 2c. 3b plus 2c. 3b plus 2c. So we already have our b to be negative 12. So our b is negative 12. So this is minus 21 equals to 3 into minus 12, okay, plus 2c, plus 2c. So this is going to be minus 21 plus, because this is going to be negative 36, comes here, become plus, equals to 2c. So this is 2c equals to 15, then c equals to 15 over 2. So we need to get our remainder. So we have the constant term to be plus 8, and here we have it to be 3c plus d. So the constant term here is 8 equals to 3d, sorry, 3 3c plus d. 3c plus d. So we have our c to be 15 over 2. So we have 8 equals to 3 into 15 over 2 plus d. So from here, we have 8 minus, this should be 45 over 2 equals to d. So d would be 16 minus 45 over 2. And that should be minus 29 over 2. So we can now come back here to say that our polynomial of x is equals to our a, we got our a to be 3, so 3x squared, our b to be minus 12x, then our c to be 15 over 2, 15 over 2, okay, then multiply by 2x plus 3, then plus, so this is going to be minus 29 over 2. So the quotient is 3x squared minus 12x plus 15 over 2, while the remainder is minus 29 over 2. You can also use a long division method to do that, but for me, I think I prefer this method to the long division method of solving it. Okay, so let's move on to the next question. So these are things you will be able to put you through more if you sign up with us at Ajiro Tech. We're going to teach you the nitty-gritty of everything you need to know, how to answer questions. When you see a question, how to recognize the topic, okay, then what you need to do, okay, and what is expected of you by the examiner for them to give you the method mark, the independent mark, and the accuracy mark. So all these are things that will put you through when you come to register with us. Okay, let's move on to the next question. In this question, you must show all stages of your working. Solution relying entirely on calculator technology are not accepted. You have to take note of that. Given that k is a positive constant, and we have this, find the possible values of k. This is a question on integration calculus. So we need to integrate this integral of k. Okay, let me start from here. Integral of k to k 12. So I'm going to write this as 12x raised to power minus 2 plus 4, okay, dx equals to 14. So it's an integration question, and we have the lower and the upper limit. So it's a definite integral. So this gives us 12x raised to power minus 2 plus 1 over minus 2 plus 1 plus 4x. When you integrate that, then we put the lower and the upper limit, k, then 2k equals to 14. Okay, good. So this will give us minus 12 over x, because this is minus 2 plus 1, that's minus 1, and it comes here, then minus 2 plus 1 equals, so that's how we have the minus here, then plus 4x, k, 2k equals to 14. So we are going to plug in this lower and the upper limit. We start with the upper limit. So minus 12 over 2k plus 4 into 2k, okay, minus, then we plug in the lower limit, minus 12 over k, that's, we substitute the value of x with k, plus 4 into k, okay, equals to 14. So from here we have negative 6 over k plus 8k, okay, minus 12 over k plus 4k equals to 14. So we can decide to remove the bracket. We have minus 6 over k plus 8k, removing the parentheses. This will become plus 12 over k, then minus 4k equals to 14. So let's deal with this. 8k minus 4k is 4k. Then we have plus 12k, 12 over k minus 6 over k equals to 14. So can we complete this? If we multiply through by k, we're going to have 4k squared plus 12 minus 6 equals to 14k. So it turns to be a quadratic equation where we have 4k squared minus 14k, rearranging them, okay, plus 6 equals to 0. We can decide to divide through by 2, and we have 2k squared minus 7k plus 3 equals to 0. Let's try and factorize this. The product is 6, and the sum is minus 7. So that should be, our factor should be two negative numbers. So that should be negative 6, negative 1. So we have this minus 6k minus k plus 3 equals 0. Let's group them. We group them, put addition here, group them. So we factorize each group, 2k into k minus 3, then minus 1 into k minus 3 equals 0. So from here we have k, 2k, 2k minus 1 equals 0, or k minus 3 equals 0. So 2k equal 1. That means k equal 1 over 2, or k equals 3. So let's go back to the question to see if we have solved what they asked us to do. The question says, find the possible values of k. And they told us k is positive. So both values of k that we got satisfies the property. Okay? So because they told us k is a positive constant. Okay? So therefore k equals to 1 over 2, or k equals 3. So that should satisfy that. Okay, can we move on to the next question?
A lot, and you're like, okay, do you have a private tuition? Don't you have? Do you have? And yes, the gel tech do have a private tuition. So by my right, you can see that we have for the Edexcel and Cambridge IGCSE, and yes, we do have for all subjects. Okay, all subjects. Okay, the popular ones that's always been in demand is mathematics, English language as a second language. Okay, we have physics, we have biology, we have chemistry, and we have um, you know the flagship, which is ICT, just here and there. We also have business studies. So if you're interested for a private tuition, I think all you have to do is send an email to the sales team at ageltech@gmail.com, and they would reply to you, talk about your time zone, talk about, and the fee is really quite affordable. Really, it's really quite affordable. It's, when you look at it across other tutoring service, I think this is the one that's quite affordable, and you get the very best of service. We also have for the E levels as well, and also for the Edexcel. So we have for the Cambridge E levels and Edexcel E levels. Okay, and we have also across the subject mathematics, which is usually the hot cake when it comes to E level. mathematics and chemistry, and then biology. These are usually one of the ones we have in demand always, all the time, even physics, for E level. So all you have to do, if you're watching this right now and you are interested for a private tuition, then you can do yourself a solid, okay, and send an email to the sales team at Ajiro at gmail.com, and they'll reply to you.
Okay, we have a question on the circle here, circle geometry, not circle geometry now, but circle equations of circle. The first one is given in terms of the general equation of a circle. Equation of circle is written as x squared plus y squared plus 2gx plus 2fy plus c equals to 0. So here, given the equation of a circle, the center, because they asked us to find the coordinate of the center. This is center what circle one. So possibly there's another circle. So the coordinate of the center is given as minus g minus f. So if we compare this general equation, the general formula here, with this equation of circle we're given, circle one, so it means here our g, 2g is equals to -6. Then g equals to -3, -3. Then 2f equals to 5. Then f equals to 5/2. But the question says we should find this coordinate of the center. And the center is in this form when you are given the general equation. So definitely the center, the coordinate of the center will be -3. That will be 3. And this will be -5/2. Okay. The second says we should find the radius of this. Now, also when you are given the center to be in this form, the radius is, we use this formula, g squared minus c. So our g is -3, our f is 5/2. Then if we come back here again, our c is going to be -41. So c is -41. So our radius is going to be -3 all squared plus our f is 5/2 all squared, then minus 41. That will give us 41. Okay, so we have this to be 9 plus 25/4 plus 41. So if we had 9 and 41, that would be 50. So we have 50 plus 25/4. That's our radius. So this should give us 200 plus 200 plus 25/4, and that will be square root of 225/4. So both of them are a perfect square. So this should be 15/2. So therefore, the radius is 15/2. So the radius should be 15/2. Okay, there's another formula we can use. We can use the completing the square formula to also get this. But I think this is far straightforward than the completing the square. The completing the square is also very good. We write the x, we bring the x together, we write it in, we complete the square, we write the y, we also complete the square. Then we can take our 41 to the other side and we do that. So that's also very good. It's also a very good formula. Some people like to use that, but it's fine. Either way, you are correct with you. Okay, let's see. We have a follow-through question. It says the circle C2 has center minus K0, where K is a positive constant. Take note of that. And it has a radius. So given that circle C1 and C2 touch, find the exact value of K. Circle C1 and C2 touch, it means they touch externally. That's what it means. Okay? It means something like if this is circle C1, then circle C2 touches circle C1 at one point externally. Okay, it touches it at one point externally. So another possible case is when they touches each other at they intersect at two distinct points. Okay, then there's something we need to do for us to get that. But for this one, they touches at externally at one point. So we have to find the exact value of K. So the first thing we need to know is we need to know the equation of circle 2. We're given the center. The center for circle 2 is minus K0 and the radius is 5. So we can easily use the standard equation of circle that says x minus a squared plus y minus b all squared equals to r squared. This is the standard equation of circle where a and b are the center. Okay, a and b are the center and r is the radius. Take note of that. So we're given all we need to have here, but we need to get the value of K. So if we plug that here, we have X minus K. That's going to be X plus K all squared plus Y minus 0. So that will be Y squared. And the radius is 5. So that will be 5 squared, which is 25. So the equation of circle 2 is written this way. This is standard equation. So they told us that we have to find the exact value of K. So if this is circle 1 and this is circle 2, the radius of circle 1 that we got was the radius to be 15 over 2, and the center was 3 minus 2 over 5. So let's say the center, this is the center, this is the center of the circle, 3 minus 5 over 2. So I think we're correct. Is it 3 or minus 3? Can we check that? Okay, the center is 3 minus 5 over 2. Okay, good. 3 minus 5 over 2. Then we also have the center of the C2 to be minus K0. Minus K. We are just taking this as a model. So since they touch externally, we can decide to find the radius here, the sum of the radius. The radius of the first one is 15 over 2, while the radius of the second one is given to be 5. So the sum of the radius, okay, is equal to the distance between the two centers. Yeah. So the sum of the radius, the distance is equals to radius of 1 plus radius of 2. And the radius of the first one is 15 over 2, while the radius of the second one is 5. So if we add this together, we have 15 plus 10 over 2, which is 25 over 2. Good. Then the sum of the radius is equal to the distance between the two centers. So we have the two centers and we have to get the value of K. So using the formula for distance between 2 points, distance between 2 points is given to be x2 minus x1 all squared plus y2 minus y1 all squared. Okay, so we have the centers to be 3 minus 5 over 2 and minus K0. So let's try to find the distance using the distance between 2 points, the length of line segment. So we have this to be 3 minus K, that will be plus K all squared, okay, plus minus 5 over 2 minus 0. So that was squared. So equals to the distance. This is the distance. So we have this to be 3 plus k all squared plus 25 over 4. The square root of this is equals to this. But don't forget we said that d is the same thing as the sum of the radii. Okay? So, and we have that to be 25 over 2. 25 over 2. So this is going to be 25 over 2 equals to the square root of 3 plus k all squared plus 25 over 4. So if we decide to square both sides, we should have, if we square both sides, we should have 625 over 4 equals to 3 plus k all squared plus 25 over 4. So we have to manage our space here for us to complete this. So if I decide to, I don't want to expand, I want to take this to the other side, I have 625 over 4 minus 25 over 4 equals to 3 plus k all square. So we have, this should be 600 over 4, and that should be 600 over 4, should be, okay, 150 equals to 3 plus k all square. So if we decide to find the square root of both sides, we find the square root of both sides. We have 3 plus k equals to plus or minus square root of 150. What's the square root of 150? That should be in solid form, I think. Okay, so let's punch our calculator. Square root of 150. Square root of 150. That's 5 of 6. So k is going to be minus 3 plus 5 root 6, or minus 3 minus 5 root 6. So, but were we given a value for k? We're told that the exact value of k, and they told us k is positive constant. So we have to pick one of them. So one of them is positive, and if we look at it, this should be a positive value. So therefore, k, you need to write that. Don't assume that it is, because this is not going to be a positive value. So k is going to be minus 3 plus 5 root 6. This should give us a positive value, and that satisfies that. Okay, the next question. Given that P and Q are consecutive odd numbers, where P is greater than Q and both of them are positive, prove that P squared minus Q squared is a multiple of it. That means it's always going to be a multiple of it. So if I want to do this, I will first try to check. They told us they are consecutive odd numbers. So let's just try to check. Consecutive odd numbers, 1 and 3 are consecutive odd numbers. Let's try on that. So if 1 and 3 are consecutive odd numbers, we can then say that, okay, let P be 3 and Q be 1. So that means it's saying that 3 squared minus 1 squared is going to be 9 minus 6. That's 8. So it's a multiple of 8. That means if you continue trying it, okay, using induction, hypothesis, inductive hypothesis, when we try for when is equals to k and all of that, we get it. But I don't want us to use that. Let's try to use something different. So, since they told us they are odd numbers and they are consecutive odd numbers, can we say that, when you say odd number, it's a number that cannot be divided by 2. When you divide it by 2, there's always going to be a remainder of 1. So we can say let P be, let's try and model 2n plus, can we say plus 1? Okay, let's say plus 1. Yeah. And let Q be, so if P is this, and they are consecutive odd numbers, so that means Q will be maybe minus 1. But I will prefer to use this to be plus 3 here. Yes, because whatever what my n is, this 2n is always going to be even. Then that means then Q will be 2n plus 1 for n, let's say natural numbers. For n, should we say natural number? Okay, let's use integers because we can also use negative numbers. So let's say integers so that we won't limit that. So let's say integers, n integers, n integers. So let's try and plug that in here. P squared minus Q squared. So we have 2n plus 3 all squared minus 2n plus 1 all squared. So this should give us 4n squared plus 12n plus 9 minus 4n squared plus 4n plus 1. So we have 4n squared plus 12n plus 9 minus 4n squared minus 4n minus 1. So 4n squared cancel out 4n squared, then 12n minus this will give us 8n, then 9 minus 1 will give us 8. So this is going to be 8 into n plus 1. Yeah. So since we say that n is integer, then n plus 1 is also an integer. And therefore, p squared minus q squared is a multiple of 8. Because whatever we have here is always integer, we multiply by 8. So it's definitely going to be a multiple of 8. Okay. The next part of the question, okay, it's not a follow-through question. I think it's a question on its own. The curve C has equation this. Prove that C has no stationary point. Stationary points are also called turning point. Okay, they're also called turning point. And what do you know about stationary points? You need to know that at stationary point, dy dx will always be equal to 0. Stationary points are turning points. If you have a curve, let's say you have a curve and you have something like this. The turning point here is a stationary point, and at this point, your gradient is 0. At this point, your gradient is also 0. Okay, it's just like you throw something up, then when you get to the maximum height, it will stop a little bit. That is how to describe it. At that point, the speed, the velocity is equal to 0. Okay, so that is what we mean by that. So we can prove this now by contradiction because they said we should prove that C has no stationary point. So let's say since y equals to x cubed plus 12x squared plus 49x plus 2, okay? So dy dx is 3x squared plus 24x x plus 49. So we have this. Don't forget we said that at stationary point that dy dx equals 0. So is there a way we can write this? Can we write it in a way whereby we show that, okay, we're always going to have a value for this. So, oh, sorry, excuse me. I think I made a mistake. This is 49x, 3x squared plus 14. Okay, 49. Yeah, that's correct. Absolutely. That's correct. Okay, so is there a way we can write this such that it's going to be in completed square form? Let's try and do that. I have my reason for saying that because we want to show that there will always be a value, and no matter the value of x you plug in here, there will always be a value. Okay, so if we try to show this, we can decide to okay, let's use this formula. Let's try to write this in completed square form. 3x squared plus 24x plus 49. So this is going to be 3 into x squared plus 8x, yes, plus 49. So this is going to be 3 into x plus 4 all squared, then minus 4 squared plus 49. So this is 3 into x plus 4 all squared. So this is going to be 16 minus 16 times 3. That will be minus 48 plus 49. So we have 3 into x plus 4 all squared plus 1. So this is our dy dx. So our dy dx is 3 into x plus 4 all squared plus 1. So looking at this, there's no value of x at which this will be equal to 0. It's always so for all values of x, dy dx will always be greater than or equals to 1 because that's the range. Okay, that's the range. It's always going to be greater than or equals to 1. So there's no value at which it's going to be x. Okay, because this will always be positive and we have to add that to this. Another way to show that is to use the discriminant b squared minus 4ac. Okay, when this one is not equal to 0, then we can also say that it has no stationary point. So those are two ways we can show that to show that it has no stationary point. So we've come to the end of the class. I want to thank you for joining me in this session. Okay, so we have so many juicy stuff for you. All you need to do is join us in Ajiro Tech at Ajiro Tech for your CAIE, that's your Cambridge AS A level. Then also for your Pearson Edexcel, we've got you covered. Okay, so for both AS and A2, we've got you covered. Join us and you enjoy more of our classes. I believe that when you join us, you're going to do well in your examination. You're going to have excellent results. We've had testimonies of students with excellent grades that join with Ajiro. So thank you for joining us, and I hope to see you again in class, in my next class. So thank you very much.